Now let me do this integral. So obviously it's not easy. You have trig functions, you have inverse trig functions, exponential functions, rational functions, and so on. It's not easy. Now let me start with the substitution. Let x equal to negative t. Then this integral becomes from positive to negative, and this will be negative t, right? This will be negative sine t, so it's still positive. Yeah. Arctangent e to the negative t, and cosine still same, no change, and the negative dt. And I use this negative to switch that the boundary becomes from minus pi to positive pi. It becomes now I write the x because they are dummy variables. X sine x arctangent e to the negative x and the dx 1 plus cosine square x. Now this is I, right? This is also I. Therefore 2I become this one plus that one. Minus to this one. And x sine x over 1 plus cosine square is the common factor. So this becomes arctangent e to the x plus arctangent e to the negative x multiplied by x sine x 1 plus cosine square x dx. Okay, good. Now we know that arctangent something is an angle. This is also an angle. Now, if we draw a triangle, this theta is arctangent e to the x, which means this is e to the x, this is 1, isn't it? And this phi is arctangent 1 over e to the x, which is e to the negative x. And since e to the x and e to the negative x, they are always positive. Therefore, the angle is it's acute angle, positive. This is positive value. Therefore, theta plus phi is half pi. So our integral becomes half pi times the integral from negative pi to positive pi, and x sine x dx 1 plus cosine square x. Since x times x times sine x is an even function, right? When x is negative, there's no change. This is also even. Therefore, the whole thing is the integrand is even function, and we can, just double it. It becomes pi. It's from 0 to pi x sine x dx 1 plus cosine x square, right? Yeah. So my I is equal to half pi times this one. I call this one is j. Okay. I just want to do the integral j. Okay. J is equal to integral from 0 to pi x sine x 1 plus cosine square x dx. Now let me use two methods for j. The first method, method 1. I use this way. Okay, this is x. This one is the derivative of arctangent cosine x. This derivative is 1 over cosine square times the negative sign, right? I have put negative, so I put a negative outside. Then this one is equal to by parts u dv, right? So negative x times arctangent cosine x from 0 to pi plus integral from 0 to pi arctangent cosine x dx. Okay, this one is equal to negative pi times negative 1 is a negative quarter pi and minus 0 plus 0 is gone, and plus this arctangent cosine x dx. So it becomes pi square 4, right? Plus this arctangent cosine x dx. Then I'm continue to do this one, right? To do this integral. The integral from 0 to pi arctangent cosine x dx. Yeah, for this integral, okay. I use substitution. Let the u be arctangent cosine x. Then tangent u is equal to cosine x. Then x is equal to arc cosine tangent u. So I can do this integral by substitution. This becomes this is u. Dx will be negative 1 over 1 minus tangent square u times the derivative of tangent u, which is secant square u, and the du. That is the derivative of x, right, with respect to u. And when x equal to pi, this will be negative quarter pi. When x equal to 0, this is a positive quarter pi. So then, this negative sign, I switch the boundary, it becomes negative quarter pi to positive pi, right? Integral secant square u du 1 plus 1 minus tangent square u. See, this function is an even function. Square. So this is 0 for that interval, right? That means this one is a 0. This is a 0. Therefore, my j is equal to pi squared over 4. Because this is 0. This is 0. I just did it. And therefore, my I is equal to half pi times j. Half pi times j. This is equal to pi cubed over 8. So that is the result for our integral by method 1. Now, I also let me do the second method for j. This has been done, with the method 1 for j. Now let me do the j for method 2. J is equal to, this is j. Sorry, you see that? Look, this is j. J is equal to from 0 to this one. X sine x 1 plus cosine square x dx. I am using substitution that let x be pi minus t. Then x will be pi minus t. Sine pi minus t is a sine t. This will be 1 plus cosine this angle is negative, right? After square still t. So cosine square t negative dt. And this will be negative pi to 0. Now then I use this negative to switch the interval from 0 . This is positive pi, right? When x is 0, this is pi, yeah. So 0 to pi, switch it up, but this negative is gone. So it becomes pi sine x, let me use x cosine square x dx minus 0 to pi t. I change the t for x, right? Sine x 1 plus cosine square x dx. Yeah, that is j, exactly j, So I move this j over there, so 2j is equal to this integral. Pi pi, this is the derivative, this negative derivative of arctangent cosine x, okay, that is, take pi out, so it becomes this one, negative arctangent cosine x from 0 to pi. So this one equal to pi times negative, this is a negative, right? It becomes a quarter pi. Minus become plus, 0 and the quarter pi again. So this one is equal to half pi square, right? 2j is half pi square. Therefore j is equal to quarter pi square, okay? Then I put it I again. I is equal to half pi times j. See? So this is equal to half pi times quarter pi square equal to pi cube over 8. The same result. See, that is the result done by the second method. But anyhow, it's a little complicated. If you trace back, carefully, I think you can follow. Okay, thank you very much for this long integral.